Good morning, everyone. How are you doing today? Thanks a lot for spending a couple minutes with me. When we're doing testing, we're testing because we want to make sure a fiber is properly installed or it doesn't have a problem. We don't necessarily have a problem with our fiber. We have a problem with the systems that are attached to it. And if the systems that are not attached to it are not working, that causes us a problem. So we want to show for sure that the fiber is working. Today, we're going to walk through the mechanics of how we do a loss test. We started with an OTDR test and some of the requirements to do an accurate OTDR test. And here's some of the steps to do an accurate fiber loss test. We're going to be running a test on this trusty demo box here, and we'll see that this box has SC Sam Charlie connectors on both ends. We're going to be running the test with the Fluke Networks CertiFiber Pro. I can read what it says on here. The CertiFiber Pro is a loss test set. And we were torn because at first we were thinking of testing just a single fiber, but this is really designed to test two fibers at a time. You see we have a multi-mode source and a single mode source. In the middle we have a power meter. The power meter can measure either multi-mode or single mode. And then on the end we have a visual fault locator. That's what I have lying down on the table here. Now, when you receive your CertiFiber Pro, it's going to come with an LC adapter here on the power meter. And we really want to set a one jumper reference. A one jumper reference is going to be more accurate. And to set a one jumper reference, I need to have an SC port because, again, I have an SC port on the fiber link that I'm going to be testing. So I'm going to take off my LC adapter and we're going to put on this SC adapter. It's got a little alignment pin here on the bottom and that should just slide right in there. And there we go. Now, I'm a little bit afraid that I'm going to be spending most of this presentation cleaning and inspecting fibers because for a fiber optic test to work properly, we need to make sure those fibers are clean. And I've got a whole slew of fiber cleaning equipment here ready to go. But the first thing we need to do is inspect. And what I'm going to start with is inspecting the output port where I'm going to be doing my transmission. So I have a single fiber adapter on here and I have a bulkhead adapter. So we're just going to slide this bulkhead adapter in here. I want you to get a good look at that. There it goes. And now over here to your left is the screen of the tester. So as I push things on the tester, you'll see it showing up there. Now we're a little bit out of focus, so let's zoom in here so we can get focus. And I've really enjoyed looking at these wide field views of my connectors. I found some interesting creatures. We may have a webinar, things that I found while inspecting my fibers. Okay, now, little bit funny looking here, but let's take a look at what we're seeing. Because when we test multi-mode fiber, we want to overfill the fiber. The core of the fiber in my source is oversized so that I can overfill the fiber. But what I'm looking for right now is I just want to make sure that it's clean, and it is. That's a beautiful looking fiber. We are ready to go. All right, so now what we're going to do, and I think one of the greatest strengths of this tester is the wizard that's going to walk us through how we're going to set the reference. If I have not set a reference within 24 hours, it's going to tell me that I need to set a reference. What is this reference setting? The way that we measure fiber is to establish a known loss value for our known cords, and once we have that known loss value for our known cords, we'll put a link in the middle. Sometimes I mention that this is a little bit like finding the weight of your suitcase. You can put the suitcase on the scale, but you won't be able to see how heavy it is because it covers up the gauge. So stand on the scale, find out what your weight is, stand on the scale with the suitcase, find the difference. There's the loss of your fiber. So we're going to start by pushing set reference. And when we push set reference, it takes us to a screen that says we haven't set up a test yet. So let's start with setting up a test. I'm going to select a new test down here, and the default value that it's giving us, we're using the CertiFiber Pro Quad we're using multi-mode fiber, and we're using this TIA limit, TIA 568.3 for fiber. D is the current revision, and Addendum 1 has been published. Now, our default is to use standard values, but because we're using reference grade connectors on our test reference cords, as we correctly should, as is recommended by the standard, I'm going to use this multi-mode reference grade connector limit. Now, what the reference grade connector limit does is it recognizes that if I put two common standard cords together, I should have less than 0.75 dB of loss. dB is a unit of measure that is used to compare two values. So just remember 0.75 dB for standard connectors, but with these fancy test reference cords, I should have better than 0.1 dB. Now, if I put two 0.1 dB cords, if I put a 0.1 with a standard cord, I'm not going to have 0.75 dB of loss. So selecting the reference grade value here is going to tighten up the loss of my first and last connector to 0.5 dB. All right, let's save that. Let's use the selected value. Now, when I push set reference, this is going to show me I really want to run the wizard. Even if I know how to set a reference, run the wizard. This is going to help you. And you'll notice that it's color-coded to match up with the cords that we're using, the red boot, the black boot. We see that the red boot is going to go into the output port of our tester, and the black boot is going to go into the input on the far side. Now, I'm just going to save this image over on the side here. Yeah, I'll come back here. Image. Maybe image. All right, we're not getting the image. So what we're going to do is cut and paste this image. Hey, look, there was traffic yesterday in Seattle. We're going to cut and paste this image because before I start, remember, we talked about a lot of inspection. I suppose when I showed that, it didn't show because I wasn't sharing it. Let's get to it. So I'm going to be using the multi-mode ports because our box has multi-mode fiber. And before I start with the wizard, what I want to do is inspect. I want to make sure that the port on my tester is in good shape, and I want to make sure that my cords are clean because otherwise I'm not going to set a good reference. So let's just check real quick here. We checked the remote tester. Let's check the main tester real quick. There's the main. We'll push test. Clean enough. All right. Now, I was using the FI3000 here for a moment because I really like it to be able to inspect inside of the bulkhead ports on the testers. But more likely, you're going to be working with our FI1000 camera. This is the standard camera. We have thousands and thousands of them out there, and I want to do this with the type of test equipment that you're using. So the red conductor is going to be going into, let's get an image there. Beautiful. Red goes to output.
Hey, Jim, hold that pretty camera up there so everybody gets a nice good look.
Sure. Oh, look at that. And that's why we're inspecting. So again, here is our FI1000 camera. This is a focus knob. Everything is in focus. And see that big glop up there? That big glop up at the top of the screen is not in the contact surface. Technically, if I run a test on this, it's going to pass the test. But I am afraid that that is going to migrate over and cause a problem. So I'm going to take my click cleaner. I'm going to just roll this in there, give it a quick click because I'm checking, and there's the tip. Now, if I hold the fiber and I stick out a finger, this helps me to align the camera just so there. And oh, look, it got worse. We're going to call that good enough for testing. All right, and I'm going to remember to plug it into the power meter. That's one cord. Now, on the other side, we're going to do the same thing. We are remembering from our little map, just skipping ahead. You can follow along, but I'm just going to preload my tester So red boot on the output of the remote tester. So here is red boot on the output of the remote tester, and black boot to the input. Now, again, that's why we inspect it. I can't tell you how many times I've tried to clean these fibers.
Hey, Jim, how can it be dirty? There was a dust cap on it.
That's a great question, Mark. How could it be dirty? Well, it turns out that the dust-holding cap is just designed to hold dust and not necessarily to keep our fiber clean. Now, depending on the type of contaminant, whether it's a dry or a wet contaminant, I may want to use a dry or a wet clean. I don't like the looks of that goop, so I'm going to use my trusty lint-free fiber. I'm going to put a drop of this special solvent designed to clean fiber optic connectors on my paper, and now we're going to go from wet to dry, wet to dry, wet to dry. Jim, I thought this webinar was going to be about loss testing, but it seems to be about cleaning. No, this is about how to do your loss tests as accurately as possible so that they come out well. So to try and keep these two fibers different, we're going to get a bunch of cords going here. I'm going to put the second fiber, we're going to be measuring two fibers at a time. I'm going to put the second fiber up on this side. And let's check that remote connection real quick. Slide the connector in. Beautiful. All right. And we'll plug it in. And go to the home key. Now we can go back to our loss test that we had previously set up, and we'll push test to start. That's a warning that I was really looking for. The wizard is there to help you do this right. Follow the wizard. And the wizard is helping me out by saying, you need to set a reference every day. It knows that I set a reference yesterday when I was practicing for this webinar, but it's recommending that I set one now. So let's follow its recommendations and set a reference. So here we go. We put our two cords on and we connected them to the opposite ends. Saw how I just skipped ahead there so I could properly inspect the fibers. So let's push set reference. Aha. Now, here is what would be a really difficult error when we're in the field. And what this is showing us is that I'm not receiving anything to the input from the main, so I don't seem to be attached to any device on the far end. Now, the problem with what I'm doing here is I haven't warmed up the tester. We really want to give it a good 5 minutes to warm up before we get started. Now, let's take a look at that reference value. No, we're not going to wait 5 minutes and eat snacks while we do that. So, what is the proper value for a multi-mode reference? Anyone? Anyone? We need a polling question for this. Yes, I can Google it and look it up, but the tester knows what the reference value should be. We want it to be between, say, -22 and -24 dBm in absolute power. So -22s are actually a pretty good value. The tester knows it, and the tester will tell you if you have set the reference properly. If you have a bad reference value and you spend all day testing with a bad reference value, -35 dBm, there's no light coming through. Those test results are invalid. We need to do it again. All right, so continuing to follow the wizard, we'll click on next. And this is very important. It's showing that we're disconnecting from the power meter, not the output. I want to leave the output connected. The fibers are aligned. The alignment may be bad, but it is what it is. And if I disconnect and reconnect, I may change the alignment of the output fibers. So,
Jim, this is where the color coding of those TRCs comes in very handy. I can never remember which end, but I can always recognize the color.
Good point. Good point. Okay, now, I got to give credit to the Corning FAEs who pointed this out to me. Before you disconnect the fiber, what are you going to do with it? Don't hold the bare fiber in your hand and wave it around and say, hey, where's the connector? Where am I going with this? Let's have a plan. Now, what I like to do, knowing that I'm needing to couple this fiber to the known good leg of the test reference cord, when I disconnect it, I'm going to put it in the coupler. There it is, protected and ready to go. Now let's take the other side. Again, we're disconnecting from the power meter, and we're just going to stick that in our connector here. Now, going back to our FI1000 camera, I need to inspect these connectors before I plug them in. And on the FI1000 camera, we have the focus knob here. On the bottom of the camera is a secret button. And if I push the secret button right now, look at that. We jump into camera mode, and I should be able to take a quick look at what is the condition of the fiber. Now, it was brought to my attention that I should follow the steps exactly of the wizard. So let's follow the steps of the wizard. The wizard is saying to plug the black booted connector into the input. So here's the black booted connector. There's the secret button. Let's take a look. Beautiful. Make sure that clicks. You'll appreciate that later. And here we're going to check the black boot of the other known good test reference cord. So here's our inspection of the other boot. That's beautiful. Now, sometimes I talk about good enough. I can see the core of the fiber there. It looks pretty clear. I don't see any contaminants. That's good enough for me. With some experience, you will be able to recognize a good and a bad fiber pretty quickly. So I'm going to try and run this fiber back here. Okay, let's go back to the wizard and see what the next step is. Okay, we're going to connect them together. So before we connect them together, let's inspect again. Secret button. Now, I don't like that glop of dirt down there in the corner, but I think it's going to be good enough for what we're trying to do here. So we'll plug that in. And back here, here is our other known good cord. Hold on to that. Check the other known good cord. Beautiful. And I'm just trying to separate these a little bit to make it clear to you. There are two fibers we're going to test. Here is an output to input, and here is an output to input. Very important here, and this is just a little bit tricky. This bright yellow save button, don't push it. Let's go back, and there we are. And here is the part that everyone who knows what it's like to set fiber is waiting to see me try and do live, especially Murphy. The TRC verification is going to verify that these test reference cords, the windows that I'm going to use to see the fiber, are in good condition. Here goes nothing. What's tricky, of course, is these are 0.1 dB loss connectors, and I want to make sure I'm getting less than 0.1 dB of loss with these connectors. And hey, look at that, 0.04 on both. We're going to screw something else up today. I know, I'm going to have to pay for that. That's a great value. Now, very importantly, this TRC 2020-0602 at 9:51, that is the time that we did this reference, and we want to save that data. So now we have our demo box. Earlier today, I inspected the ports of the demo box to make sure that it's clean, and I am not going to re-inspect them because I see we are going over our dreaded 15-minute limit here. So let's just accelerate a tiny bit, plug our cables in. Come on, up. Plug our cables in. And my final connection here. All right. We'll say next. It says disconnect. It says put the link you're going to test in the middle and push test to start. 3 seconds, 2 wavelengths. Loss, length, save. Our work is done. We're going to save with the cable IDs we have. And to wrap this up, we're going to sync and we're going to send these test results up to Linkware Live. Why am I going to send them to Linkware Live? Well, because I don't want to lose the test results between my house and my office. Actually, in this case, I have this really Oh boy, if you want to have a worse project manager, I have a project manager who really knows what's going on. And that's tough on me because I know that he's going to look very carefully at those results and make sure that we've done this right. So Adrian, let me toss you the ball. And do you want to take a look at those test results and see if they're looking good for us?
Yeah, I'll give that a go.
We certainly can do that. Let's set Adrian up now so we can see. So what Jim did is he's uploaded the results to the cloud, and now we have a special guest who's coming in, Adrian Young, who is going to show us now how he's going to access those results and check up on Jim's work from what are you probably 50, 60 miles away from Jim, right?
Yeah, about 50 miles. We are socially distancing quite extreme today. All right, I'm going to see if I can pick the right screen to share. That's always a challenge, of course, and I think it's going to be that one. So let me share that screen.
Here it comes. We've got it.
Okay, cool. So this is Linkware PC, the software that people have been using all the way since 2001. It's been around forever. Some people say it's like the de facto standard. To save time, I've already clicked on the Linkware Live icon, and here I can see Jim's project, so I'm going to click OK. As I click OK, I've got 4 results to import, so I'm going to import those 4 results. And I'm going to sort them by date and time. And the reason why I'm doing that is, and this is really important, look what we've got here. This is the TRC verification that Jim did, and I can see that his test codes are in really good condition. That gives me supreme confidence that these measurements after that have been done using a one-jumper reference and are going to be reliable, accurate measurements. If I don't see these TRC values, I have no idea how good Jim's codes are. And then if you start seeing failing links in here, then you've got to ask the question, well, is it the TRCs that are bad or is it the link that's bad? But by having these TRCs here, we know that the test codes are in good condition and I can feel really good about my fiber test results. And that's it. Up to Linkware Live, back down onto your PC. And if one of Jim's kids decides to play fun with him and delete the results off the tester, it's not the end of the world because the results are still in Linkware Live. So if we can, Mark, go back to Jim's screen just for a moment, I'd just like to end one other additional comment.
Yes, the social distancing comment.
Yes, the social distance. Yeah, we haven't rehearsed this at all, have we? But
there you go, Jim. You're ready to present.
Okay, thanks. Let me share these again. Bear with us one sec, folks. There's our tester, and here is our image.
Right. So what I wanted to say, and this is really important, we can joke about this, but maybe not. For the purpose of this demo, Jim has the testers side by side. That is not ideal. You really don't want your test codes all called up like that. It's not ideal. And so typically we recommend keeping the testers at least 6 feet or 2 meters apart, which is interesting because that's currently social distancing. For all you copper guys out there, that exact distance is 1 wavelength apart at 146.52 megahertz. So that's the distance you really want to keep them apart. Because if you start calling up the chords, then what's going to happen is your reference is going to be a little bit on the low side because you're putting bends in the fiber. And then when you straighten out that fiber, your result's going to look optimistic. And that is one way how you get negative loss results, which ends up failing on the tester. So with that said, we turn the 15 minutes into 30. Good job. But as somewhat predicted, there were issues in cleaning. And what I really want to say to the project managers out there is, please, I beg you, give the technician time to set up the tester. If you allocate 15 to 30 minutes in setting up the tester and setting the reference, your testing is going to go a whole lot smoother. I totally understand you arrive on site, your gear showed up late, you've got to get testing, but again, I'm begging you, please allow the time in the setup here, because once you do this and you go off testing, things go really quickly after that. So with that said, Mark, back to you.
Thanks, Adrian. And we're going to do some questions and answers here in just a second. First, I'm going to push a poll question and let people have a chance to let us know if they would like one of our experts to contact them. Now, this one we will be recording your name, but if you'd like somebody from Fluke Networks to contact you about this, then go ahead and answer that question while we're answering some of your questions. Anyway, let's get to some of the questions that have come in. See if I can find those. One of the first ones was, where did that one go? Shoot, I see it. There, now it went away again. Sorry, this is what happens when you do these things live. You sometimes lose things and you find stuff. Oh, Jim, there were some questions about the fiber inspection cameras that you showed. Could you put them on screen and just mention their model numbers and a little bit about them?
Sure. So many people are familiar with the FI1000 inspection camera. This is the default camera that we ship with our kits. I can adjust the tip here to switch between SC or LC ready connectors. The other camera that I was using today is our fairly new, the FI3000. The FI3000 can be connected. We saw it connected with USB cord to Versiv to help look at the screen. Another interesting option with the FI3000 is that it can be run from a cell phone. So if you have the app on your phone, let's pretend I have the app on the phone and it hasn't expired, I can see the fiber end face from the camera, and that will allow me to both grade the end face images and, more importantly, store the end face images. If you have a clean connector, if you left a clean connector, save that end face image of the clean connector that you left behind in the event that the next person who comes along plugs in a dirty connector. So that was, again, the FI3000.
And for those folks who are in environments where Wi-Fi devices are not permitted, both the FI3000 camera there and the Versiv you see on the screen there, both come in a non-wireless version. And we're seeing an increase in people saying they're actually installations where Wi-Fi enabled devices are not permitted. So again, you can get the FI3000 where the Wi-Fi is disabled and there's no ability to turn that back on.
Good point, Adrian. Let's see, we're not getting too many questions today, so maybe we're making up for this one by going a little long, but not having too many questions come in. That really is like,
Mark, here's a common question. I know that we're way over our time here, folks. I understand if you need to run away, you have other things to do. But one thing that I wanted to point out is the importance of the loss value that you choose, the loss limit that you choose. Now, we're using, as we saw before, and let me bring the tester to the front of the screen here. We saw before that we're using the TIA limit. Now the TIA limit, as we add more cable, more connectors, we're going to have additional loss budget allowed. So right now, I have told it that there are 2 connections and no splices. The tester doesn't know how many connectors there are here. So let's run this test with 2 connectors and 2 splices. We know it's going to be pretty quick. And let's remember these loss values that we get. So on the one fiber, we're getting .66, and on the other fiber, we're getting .67. Now, if we drill in here, we can see that the loss limit is 1.16. That would be one connector at .5, a second connector at .5, there's 1 dB, and 50 meters of fiber at 3 dB per kilometer. We've actually measured 53 meters of fiber. I do have a 2-meter receive cord on the end of this, so 53 meters at 3 dB per kilometer is going to be .16 dB. So that's why we have a limit of 1.16 dB. Now, let's go back to our setup screen. And in our setup screen, we're going to change the number of connectors to 4. And you see, we're seeing graphically that this is representing 4 connectors. There are not 4 connectors here. Let's watch what happens to our loss value. When we run the test, what we're going to find is the loss value stays the same. Look at that, still .66 and .67. But what we have changed is the limit. By adding 2 additional connectors at .75 dB each, we took that 1.16 and we added 1.5 to it, which is giving us the 2 I can add, the 2.66 limit. So again, the limit is what we're going to tell the tester our requirement is, but the actual loss value won't change irregardless of what limit we're using. Let's do one last fun one here. And instead of using a TIA limit, what I'm going to do is select an application limit. So we'll go into the test limit here. We'll click More and Applications, and let's say that we want to use the test limit for 10G base SR. We'll save that, you select it, and we'll run the test. Now again, hopefully we're going to come up with .68 and .66. Those couple of hundredths of variance, nothing to be worried about. But notice that my loss limit changed to 2.6 dB, and just at the 850 window, because the limit we selected, 10 gigabits short, only runs at 850, and it has a fixed limit of 2.6 dB, it doesn't care how many connections there are. All right.
And that remote connection drifted by 0.02 dB, and that's probably the fact that your remote unit was actually switched off.
Yeah, could be that. Could be that I touched the fiber. Again, hundredths of a dB, I'm less concerned about. And you will see those tiny variations.
All right, great. Well, this is your last chance to get in a question if you've got a question you'd like our people here to answer. But if not, I guess we're going to let you get back to your regular job, your day job, or your night job, depending on what part of the world you're at. Thank you very much, Jim and Adrian, for giving that great demonstration and answering the few questions we got. For everyone else, have a great day.